Let's turn our attention now to how we actually sketch the graph of a quadratic function. Let's say we have the quadratic function f of x equals negative 2 times x plus 2 all squared plus 5. That's not standard form, is it? No, it's not. It's another form that we're going to name in a moment. But let's take a look, just for a second, at what the graph of this thing looks like on a calculator. We'll have negative 2, x plus 2, all squared, plus 5 graph. So, what's going on with this graph? This is a parabola that opens down, which suggests maybe this number that I'm multiplying by my binomial, if I multiplied this out, this might be a. And in fact, we can see pretty easily that if we multiply this out, that will be a. This number is our leading coefficient. It still tells us if our parabola opens up or down. All right, where's my vertex? Let's trace. It looks like the top point on my parabola might be somewhere around x equals negative 2. Let's consult the table to make sure of that. So my parabola goes up. At negative 2 it turns around and comes back down again. And just looking at the pairs of numbers in this table, my axis of symmetry definitely runs through negative 2. So my vertex is at negative 2, comma 5. You know what happens here? My graph turns around where the thing I'm squaring is 0. This is a lot like what we saw when we graphed the absolute value, right? The absolute value function had its pointy bit where the thing inside the absolute value was 0. If I have a parabola given in this form, my parabola has its vertex where the thing that I'm squaring is 0. Because we can easily read off the vertex in this form, this is called the vertex form. The vertex form of a quadratic function is f of x equals a times x minus h squared plus k. These letters h and k, they're standard for a parabola with the vertex at the point h, comma k. Remember, the vertex is where the thing I'm squaring is 0. So it's x minus the x-coordinate of the vertex plus the y-coordinate of the vertex after we square. Okay, so let's say we wanted to graph a parabola by hand. And we already had its equation in vertex form. What do we need to know in order to graph a parabola? We need to know where its vertex is. In vertex form, that's taken care of. Then we need to know if it opens up or down. We can tell that by just looking at this leading coefficient. And then we also need to know how wide or how narrow it is. Right, what do I mean by that? Well, compare for a moment the graphs of x squared, 1/3 x squared, and 2x squared. 2x squared is really narrow compared to 1/3 x squared that's really wide. And this is how we're going to get ourselves positioned to open in the right direction, up or down, and to have the right width or narrowness for our parabola. So in order to graph a parabola, first we're going to plot the vertex, of course. And then we're going to plot two symmetric pairs of points. What do I mean by that? I mean 2 points to the right of the vertex and the 2 points to the left of the vertex that are symmetric to those. This is most easily seen by looking at an example. Let's suppose we want to graph the quadratic function h of x equals 1/2 x minus 3 all squared plus 2. Because this is in vertex form, we can immediately read off the vertex. For what value of x will x minus 3 be 0? Well, 3. What will the y-coordinate when x is 3 be? Well, this term's going to work out to 0 when x is 3. So we'll be left with just the plus 2. Okay, so now we want 2 points to the right of my vertex. I'm going to pick x equals 4 and x equals 5. Plugging in, h of 4 will be 1/2 4 minus 3 squared plus 2. 1/2. 4 minus 3 is 1. So 1/2 times 1 is 1/2 plus 2. That'll be 2.5. Plugging in 5 for x, I get 1/2 5 minus 3 squared plus 2. So 1/2 2 squared plus 2. 1/2, 2 squared is 4. 1/2 of 4 is 2. So this will be 2 plus 2 is 4. We're not going to compute these again to get 2 points to the left of the vertex. Instead, we're going to make use of the symmetry. Remember, the axis of symmetry runs through the vertex. So the point that is 1 to the right of the vertex should be at the same height as the point that's 1 to the left of the vertex. 1 more than 3 is 4. 1 less than 3 is 2. 2 more than 3 is 5. 2 less than 3 is 1. All right. Now I'm ready to actually graph this. I'm going to draw my axes and make sure that I see all 5 of these points. And noticing that I'm going to want to graph a half, I think I'm going to scale my axes so that the halves come on grid lines. So it looks like these axes will do everything that I want. I'll plot the point 3, 2, the point 4, 2.5, the point 5, 4, and then the symmetric points 2, 2.5, and 1, 4. All right, these seem to outline sort of a parabola-shaped curve. I'll fill that in, and my graph is going to look something like this. There are a couple of things that I want to call your attention to about this hand-drawn parabola that it's important to replicate when you're drawing a parabola. The first one is that it's smoothly curved all the way around, and especially it's not pointy at the bottom. Right? Graphing a parabola is not a game of connect the dots. We draw a smooth curve that goes through the points that we plotted. The other thing I want you to notice is that up beyond the dots, the parabola continues to go outward. It doesn't curve back in. This is the graph of a function. And that's all there is to graphing a parabola if its equation is in vertex form. I'm going to give you one of these to try. Graph the function k of x equals 2 times x plus 1 all squared minus 3. In this way, by plotting the vertex and 2 points to either side. Pause the video and try this now. All right, to find the vertex, we'll look for where x plus 1 is 0. So that'll be where x is negative 1. And then when we plug in negative 1 here, this whole term is 0. And we're just left with negative 3. 1 to the right of negative 1, I'll find 0. And 2 to the right, I'll find positive 1. 1 to the left of negative 1, I'll find negative 2. And 2 to the left, I'll find negative 3. I'm going to prefer to plug in these positive numbers because they make the arithmetic easier. 2 times when x is 0, this will be 2 times 1 squared is 1. So 2 minus 3 is negative 1. 2 times 1 plus 1 minus 3, that's 2 times 4 minus 3. 1 plus 1 squared. 2 squared is 4. This is 8 minus 3 is 5. So that means when I draw my axes, I need to make sure that negative 1, negative 3 is on my graph. I need to make sure that my x-axis extends out to negative 3 and at least to 1 on the right. I need to make sure my y-axis extends down to negative 3 and up to positive 5. All right, so my vertex is at negative 1, negative 3. And then I have points at 0, negative 1, at 1, 5, and then the symmetric points at negative 2, negative 1, and negative 3, 5. Connecting those with a smooth parabola shape, I get this parabola. Notice that this is quite a bit narrower than the previous parabola that we drew.